Here we have a pre-calculus problem. Okay, let's go with the information. Consider the functions below. F of x equals to square root of x positive 4, g of x equals to x over 3. Determine the domain of f dot g. So this is a composite function. That is the composition of two functions f and g. Okay, so to get the domain of a composite function, first we have to find f dot g. That is a composition of two functions. Let me do it. So the formula to get f dot g is f of g of x. Okay, let me write it over here. Now, we know the stuff that is equal to g of x, that is x over 3. So we can plug in x over 3 for g of x over here. Then I'm getting f of x over 3. Okay, already we know the stuff that is equal to f of x, that is square root of x positive 4. So here, at the place of x in f of x, we have x over 3. Now, to get the stuff which is equal to f of x over 3, what I have to do is, in this expression, I have to plug in x over 3 for x. Okay, then I'm getting square root of x over 3 positive 4. Okay, now I got the composition of two functions, that is f dot g, or we can say it as a composite function. Okay, now let's discuss how to get the domain of a composite function f dot g. Whenever I want to get the domain of a composite function, in this f dot g, first I have to identify the first function and the second function. Usually the first function is g of x that we have in the square bracket over here. So this is the first function, and this f is the second function. Okay, so the domain of a composite function is the same as the domain of the first function, that is g of x, or it will be within the domain of the first function. So for that, first we have to write the domain of the first function g of x. So g of x is x over 3. So here, for all real values of x, g of x is defined. So now let me write the domain of the first function, that is g of x. So domain of g of x is all real values. Now, the domain of the composite function can be the same as the domain of the first function g of x, that is R, or otherwise it has to be within the domain of the first function, that is the domain of the composite function can be the subset of this R. Okay, so for that we have to find the domain of the result of the composite function. So this is the result of the composite function f dot g. Now let's find the domain for this one. So if I want this stuff to be defined, so the value we have inside the square root has to be either 0 or positive. If I have negative value inside the square root, then it is considered to be imaginary or undefined. So the value of this expression x over 3 positive 4 inside the square root can either be 0 or positive, that is x over 3 positive 4 is greater than or equal to 0. Now let's solve for x in this inequality. So for that we have to subtract 4 from both sides. When I do so, I'm getting x over 3 greater than or equal to negative 4. Now to get this 3, I have to multiply both sides of this inequality by 3. Now let me do it. So when I do so, this 3 will cancel. I'm getting x greater than or equal to negative 12. So this is the domain of the result of the composite function. Okay, now I got the domain of the first function, that is all real numbers, and also I got the domain of the result of the composite function, that is x greater than or equal to negative 12. Now to conclude the domain of the composite function f dot g, what we have to do is we have to sketch both the domain of the first function and the domain of the result of the composite function on the real number line, and we have to consider the common region. Okay, now let me sketch it on real number line. So now let me draw a real number line over here. On the right side extreme we have positive infinity, and on the left side extreme we have negative infinity. And so here let me mark the value negative 12 on the real number line over here, because here we have negative 12. Okay, now first let me sketch the graph for the domain of the first function. This is all real numbers. All real numbers means like I have to cover the entire interval, that is from here to here. Let me draw over here. The black color represents the domain of the first function. Okay, now let me sketch the domain of the result of the composite function, that is x has to be greater than or equal to negative 12. So x can be equal to negative 12 or greater than negative 12. Since x can be equal to negative 12, so I have to take a filled circle over here, and since x has to be greater than negative 12, we have to draw a line up to positive infinity. Now we have to find the common region of these two graphs. Clearly this part is a common region for the two graphs. So this one represents x greater than or equal to negative 12, or in interval notation we can write it as a negative 12 comma positive infinity. So this is the domain of the composite function f dot g.